Okay, I think we're about ready to go. Welcome everybody to our AI webinar. A big thanks to all of the guests who've managed to make it here today, especially to our speakers. So today we've got Martin Myers, UK and Ireland CTO for Fujitsu. He's going to be talking to you about Fujitsu's AI journey and looking at a couple of case studies on how AI has helped businesses manage to achieve a step change in their efficiency. We've also got Tam Dipper, who's an AI business analyst, who's going to join us. He's going to help demonstrate the risks and also the opportunities for SMEs looking at engaging in an AI project. So hopefully we will be able to bring some value. Obviously your time is incredibly precious, so we're keen to make sure that you get something out of this. For those of you who haven't come across me before, my name's Duncan. I'm Commercial Director at Primenet. Primenet are a technology solutions provider. We've got a pedigree for delivering services across UK and Ireland. At our heart is quality. We want to make sure that every single thing that we do is done to the very best of our ability. Why are we doing an AI webinar? It's because we've had lots of inbound requests from our existing customers. They want to understand a little bit more about exactly what they need to do to engage in a project and get something meaningful out of it at the far end. So where we focus is in delivering technology solutions across the modern data center, in the cloud, and also at the edge. We are the infrastructure people. So when we deploy a solution, we are able to put a services or wrap around it so that the customer ends up with a turnkey solution. How do we go about doing that? We work with a network of consultancy providers, also our own internal consultants, to help analyze a problem, whether that's a case of looking at enabling DevOps or helping people to manage their information and data better, so that we can help our clients achieve benefits through the combination of our solutions and our approach. These are the kind of people that we work with. A lot of these are buying our managed services for data center focused projects, but at the same time, we keep cloud services providers ticking. We help ISPs and various other MSPs deliver their core services out to their client base. So that's a very brief introduction to Primenet. At this point, I'm going to hand over to Martin, who is going to talk to you a little bit about Fujitsu's posture around AI and their AI journey, and look at the case study. So handing over now. Thank you.
Thank you, Duncan. So I'm going to talk briefly about three particular aspects initially. So I'm going to talk a little bit about Fujitsu and its journey in AI and why we think it's important and why we're investing quite considerable amounts of money in it. I'm then going to talk about how we think AI is going to influence and shape the service desk environment, both now and looking forward into the future. And then I'm going to talk a little bit about a real world use case where we used AI with one of our customers and really produced a transformational effect on their production line and enabled them to deliver significantly more capacity through their plant. So first slide I'm going to show then is it's an overview of Fujitsu's AI journey, and the first bit on here is the little bit in the bottom right hand side. ZINRAI is the phrase that we're using to describe our whole AI approach. So everything to do with AI is encompassed within the ZINRAI framework. And the Japanese characters underneath there are the depiction. The Japanese word ZINRAI means as fast as lightning, which is really much the approach we're taking. We're trying to deliver benefits using AI as quickly as possible. So ZINRAI is now embedded throughout our corporate structure. So it's not just a Japanese initiative, it's pushed across all of our operating countries. It's got strategic importance, and that's because of the transformational effect that we think it's going to have on society, and on our view of that is the human-centric innovation. So how does it affect us as human beings going forward, and is that transformational in our dealings with the service desk, or is it transformational in our dealings with a major utility provider? We see it as improving outcomes within both commerce and industry, but also as well as in society as a whole. So it's not just a business-to-business initiative. There's also business-to-consumer initiatives to take into account too. And I'll talk about some of those specific areas shortly on this slide here. So these are 8 different subject areas where we are looking at specific opportunities to deploy AI techniques to improve the current scenario. I'm not going to go through all of them, but I'll pick a couple initially, and I'm happy to take questions on any others later. But looking initially on the top right at the finance sector, some of our larger customers in the financial sector are using AI techniques now to analyze transactions and identify those transactions which are potentially fraudulent and take action on them at the point the transaction is taking place. Now, they've always been able to analyze transactions retrospectively and identify them, but now the AI techniques that are being deployed allow them to do that in real time. So there's wire speed AI analysis of transactional data, which is able to pinpoint and stop transactions prior to the transaction completing in real time. That's quite a significant development for those large customers. The next to the left there, it talks about logistics, and we'll talk about logistics in quite a few AI applications. The obvious ones are in route optimization, so enabling the machine to calculate the optimum route, taking into account not just the journey distance, but also the prevailing traffic conditions that will be there at the time when the vehicle gets to that point in the route, and also to optimize the loading and unloading schedule for the vehicle so that the right components or the right packages are at the back of the bay at the right time, etc. On the left-hand side at the top, we've got a focus on utilities, obviously a very significant market in Europe and the rest of the world. And again, things like network optimization, so using AI techniques to optimize the routing of traffic, or optimizing the routing of fiber optic networks, or optimizing the routing of cellular tower infrastructure for mobile communications is a key focus. On the left-hand side at the bottom, we've got manufacturing, and there's a whole swathe of different initiatives underway, ranging from optimization of drug discovery, and also I'll talk about a specific use case a little bit later where we optimize the factory floor significantly. Healthcare, big topic at the moment with Donald Trump over and his discussions in that field. But already we're starting to see some initiatives using AI techniques to optimize health screening. It's an area where, obviously, with an aging population, Fujitsu is a Japanese organization, and it's an older population. It's about 10 years older in Japan than it is in the UK. We've already got some key learnings from Japan that we can start to bring across into the European domain. And then on the bottom on the right-hand side, in retail, we're doing some really quite interesting work with in the Far East, analysing in real time customer sentiment as they journey through a department store, looking at things like the dwell time, the facial expression, the stance and the gait of the person as they move around and interact with the store environment, and that bringing those to reality for the customer and enabling them to optimize store layouts is quite a key area which we'll be developing and bringing forward into other sectors soon as well. So just one little bit here about what's in Fujitsu's AI kit bag. So I'll talk about these just briefly. Everybody should be vaguely familiar that Fujitsu produces a range of x86 servers, so standard Intel architecture x86 servers. These are under the Primenet brand, and these are all support GPUs in multi-GPU configurations and can be optimized for artificial intelligence and machine learning applications. Those are available now and have been for some time and will be for quite some time going into the future too. FAIR is the Fujitsu Advanced Image Recognition System. So this is taking the architecture in the Primenet range from above and applying a specific framework to it within the ZINRAI framework, and deploying that to artificial intelligence image recognition tasks such as non-destructive testing or such as the drug discovery work that I mentioned earlier. And we'll talk about that one a little bit later. The ZINRAI deep learning system is our comprehensive AI framework, which wraps around not just the physical technology, but also the software infrastructure and the data scientists and analytics required to develop a full AI platform. That will be available within the next few weeks, this quarter. And then in Japan, we're developing some specific hardware. I think most people will probably be aware that today a lot of AI is performed by GPUs, general purpose graphical processor units. Fujitsu is at present developing its own specific version of that called the deep learning unit. And this is as I say, it's a specific piece of hardware aimed at AI. So rather than the GPU being general purpose, the DLU is specifically designed to do the tensor mathematics that is at the heart of AI. And it also incorporates some rather unique technology from our supercomputer range in the way that it uses some internode connectivity, which is quite unique. And then finally on that page, we're in discussion and in development, of a very large machine in Japan, which has been in the press recently. It's called the Post-K machine, and it will be installed at the Riken Institute. And when it is launched, it will be a very, very large machine. But at its root, it has also been designed to do not just high performance compute and supercomputing, but also developed so that we can switch it into an AI mode and significantly increase its speed and tune it towards AI style applications. And that will be available delivered to that customer towards the end of next year. So as you can see, there's some stuff which is available now, and we've got some exciting stuff in the roadmap going forward as well. So now I'm going to talk about how we think AI is going to work in the service desk and call center environment. It's an area where, obviously, as a large IT services organization, we've got some skin in the game, and I've been developing this with our own scenarios in mind, but also looking at how customer service desks and how end user service desks work as well. So this is with respect to not just internal IT service desks, but also with respect to how a banking customer may interact with their bank service desk, for example. And very much we see that this is a developing workforce and customer expectation. Gone are the days of the old service desk where information was rarely kept and would call you back, and you might hear from them again. People expect, customers, users, workforce colleagues expect the right answer the first time from the service desk, and we are using AI to help develop the techniques to deliver that. Always on, always learning. So in an old scenario, you might have created workflows for service desk agents which were pretty static and delivered the same information regardless of whether that was successful or not for some time. Now we expect the service desk agents to deliver the information per the script, but the script may well change from time to time as the AI engine behind it corrects information or optimizes the call route, etc. As I said at the beginning, the workforce is changing. And 10, 15 years ago, the acceptance of a human-machine interface was pretty low among the general population, but that has changed and is changing as we move forward. So people are more readily able and more readily expecting to interact with a machine as an interface. And that enables us to get things like the first time fix, the correct response first time, get that delivered first off. So the way that the machine can interpret the instructions or requests from the user are better refined and able to deliver the correct response first time more often. Increasing flexible working regimes. So shift patterns are pretty irrelevant to an AI platform. Users can interact with the system at the time of their choice rather than at the call desk hours that are dictated by traditional working patterns. And this leads to an increased focus in end user experience. So how does the user perceive the system? That's also part of the AI learning exercise. Is the end of the call, does the user provide feedback about the keypad, or is it just a straight hang up, or etc., etc.? And how do we mine that data to improve the specific scenarios of people who are calling at one time of the day versus the scenarios of those that are calling at a different time of the day? And then increased personalization. So knowing who you're interacting with and knowing them in detail, using the AI to understand what that particular user's requirements and demands or physical characteristics may be, so that the user then feels an increase in value from that interaction and has got a greater perception of the service as a whole. We take a multi-dimensional approach to doing this. So one factor I've already spoken about there is the human-machine interface and how we optimize that, using things such as, and we've all interacted with them, artificial agents and chatbots as a precipitator for the call. So at the very inception of the call can be via an AI chatbot. It works quite successfully in some scenarios. We use it to reduce the time on task for the service agent. So that's optimizing the resource distribution within the service desk and allowing service agents to actually focus on something which really does require human interaction rather than the initial part of a call, which could be automated. It reduces downtime because it gets, as we said earlier, it gets the first time fix in place at an earlier point. But the other aspect of that, the other dimension, is the predictive analytics. So looking at constantly every call, every part of every call that takes place, using the data that we can extract from that to improve the process going forward. Also using things like using things like anticipated failure in advance techniques. So looking at machines that are deployed across large banking estates, ATMs, for example, how we can interpret the data that's currently not utilized effectively, transactional data and errors that take place within the ATM. How can we ensure that data is mined and then used to predict when failures might occur in the future? There's some really interesting projects underway in Europe where we are predicting for some customers that an ATM may fail, scheduling an engineer and going and fixing the machine before it's actually gone wrong, which improves their availability significantly. In future, the service desks are going to be a little bit different, we think, and those are driven by the way that we interact with them. We're going to really need to understand the needs of the workforce or the customer base. We're going to have to use the automation and intelligent automation to ensure that those routine, mundane tasks which currently occupy quite a bit of the service agent's time are done autonomously, so that we can redeploy the service desk agent. Omni-channel support is not my favorite word, but yes, interacting via mobile phone, via voice, via email, via script and chatbot, I think is going to be increasingly prevalent. And then biometrics as well. So you will have seen there's quite a bit of focus on security nowadays, and how we can use biometrics, voice print analysis, etc. for authentication. I myself spent 10 minutes the other day reading a script to a banking machine, which now recognizes me when I log on through an AI platform just by the sound of my voice. And then lastly on there is probably one of the most important ones, is how we use AI to monitor customer satisfaction, to ensure that we then constantly learn, constantly improve. And that's something which AI can bring as a platform quite readily, and it's quite difficult to do using organic resource to do that, because it's time consuming, costly and expensive. And I'm going to talk about a specific use case. So this is a use case which where we used an AI platform. It's the Fujitsu Advanced Image Recognition platform that I mentioned earlier. And we used that in a non-destructive testing scenario to improve a customer's factory process. So just a little bit of background first. This is with respect to the UK. We'll all have seen the increasing numbers of wind turbines that have been deployed across the countryside, and some little stats there on the bottom right-hand side. The current turbines are in the order of, the ones that have been developed are in the order of 15 megawatts per turbine, and the height of those is about 265 meters. They are quite large things. You see these mainly at the top of mountains or mountain ranges, and quite a lot out at sea, because the size of them, they are quite easy to spot from quite a long distance away. Now these machines are rather heavy, and one of the stats that we learned from this process was that each kilogram of weight that goes into the blade requires 100 kilograms of additional weight underneath it to support it. So the increasing the mass of the blades is not a desirable effect, because that has a significant cost impact on the overall tower structure, the bearings that let it rotate, etc. But it's a successful process, the wind turbine generation. And a little page here. This is taken from March last year, and you can see at the top middle-ish of the page here that we were burning an awful lot of coal last year on the 3rd of March. And that, if you cast your mind back, this was the time when the prevailing wind was from the east, and it was called the Beast from the East. And we were in full production using coal. Nuclear was running quite high, and we were burning a lot of gas as well. Actually, our wind was relatively low at about 5 gigawatts, because the wind was coming essentially from the wrong direction. Most of our prevailing wind is from the west, and the Beast from the East was from the east, obviously. Rolling that forward by a year, you can see the coal has dropped right down to zero. We're still running nuclear because that's efficient. Gas had gone down a bit, and wind was now up to nearly 10 gigawatts. This is on the 17th of March this year. The wind was more favourable. It was normal prevailing conditions, and that was the significant effect that had taken place. Also, during that time, the country has deployed quite a lot of solar panel and renewed and improved its wind infrastructure as well. So there's a very steady progression in the right direction on that. So I mentioned that they're big and heavy. The photo of the back of the lorry, that's one blade being transported. The blade is about 75 meters long. You can see what happens when they go wrong. The picture on the bottom there, which shows a wind turbine where the blade has shredded. Actually, that's quite lucky, because quite often when that happens, the blade hits the tower and the entire tower falls down. So there's some good pictures and videos on YouTube of that if you're interested in that kind of thing. And then on the left-hand side, I mentioned earlier, each kilogram on the blade is 100 kilograms in the tower, and that shows you the size and scale of that's the main gimbal that the overall top bit of the tower rotates on, so it can track the wind. It's made of steel. It's extremely heavy. Very expensive, and when the blades fail, that bearing gets significantly damaged. There's some statistics being calculated on the right-hand side of the page. If you had a catastrophic blade failure, it could cascade through the wind farm and destroy quite a bit of equipment, and it could result in quite a long-term outage and a significant bill at the bottom of the page. I'll just show this slide, which shows why that is. Somebody got a really clever picture here, just with a bit of sea fog going through the wind farm. But you can see that in this particular scenario, the wind from one the wind from one blade passes then over the next blade and the next turbine and the next turbine, and that's the kind of scenario where they are concerned that one blade failure at the beginning of the front of that farm could cascade through the farm and cause quite a lot of infrastructure damage. So what do we do about AI? This is a picture of our customer's factory, and this large thing in the middle of the screen is a mold that they make the blades in. You can see the scale. It's 75 meters from the far end to this end, and there's a chap there in his yellow vest who's looking at that blade. And this is a key part of the process. The blades are made in two halves, and that's the half a mold there, and the blades are then joined together. So the two halves are joined, and that process is critical because that's the weakest part of the blade itself. So the customer uses ultrasound to scan the blade, and he has a 6-headed ultrasound scanner, and it goes around the entire seam, and the seam is 75 meters in each direction, so that's 150 meters times the 6 heads of the scanner is 900 meters of ultrasound, which is then examined. And in the current process, that is done manually, and a quality assurance technician physically scans line by line meter by meter the ultrasound scan that's produced by the quality assurance process. And as it says on the screen there, each blade takes between 6 and 8 hours for him to check. It's an intensely labor-intensive process, and one which the customer asked us if we could apply an AI technique to help resolve. So that's what we did. And what did we do? Okay, so we have under development at the time, and it's now in production, a system called Fujitsu Advanced Image Recognition. It was designed to use an AI platform called a convolutional neural network to examine images, and the theory is that we would train it to recognize certain things. We then feed images into the machine, and it would identify those things, whatever they might be. And the key targets for this were things like non-destructive testing, of which this is one example. Also the drug discovery, which is the Petri dish diagram on the left-hand side center. And then also at the top is automating production line processes. So that's using this machine to recognize specific components as they go down a production line. What do we actually do with that? Okay, so we take an image, and in the case of the wind turbine manufacturer, we took about 50 images, so 50 times 900 meters of ultrasound. We'd taken these images from the QA process, as the QA engineer had already marked on them where defects were suspected. And we used those images then to train this convolutional neural network, this AI platform. And we trained it to recognize what does a good blade look like versus what does a bad blade look like, and actually specifically identifies the particular location on the blade that needs to be re-examined, not just the entire blade. This is the picture of what it looks like. So that's the output from the image recognition system, and you can see this long bar at the top here is an image of the overall blade. And these little black blobs here are where the AI platform has said there may be a defect here, which you might want to go and check before you issue the QA certificate. And then it gives in here the detail of this is exactly what that particular bit of the blade looks like. And you can see in some areas there's wrinkles in the fabric here and here in particular. And these are the bits which need to be examined by the QA engineer. So what does that mean going back to the factory? Well, using this platform now, whereas each blade did take between 6 and 8 hours to check, the QA engineer is now directed to the specific points on the blade that need to be examined, rather than looking at the entire 900 meters of ultrasound output. And the effect of that is that it's reduced the time on task from about 7 hours to down to about 1.25 hours per blade. So that means that the customer is now able to increase his production capacity by several fold without having to invest in any additional QA resources. And that was actually the limiting factor in their production line at the time. So we've used this platform now, excuse me, we've used this platform now to increase their capacity significantly with no additional cost. So they can use the same molds more effectively, same production line, same factory footprint, and using the engineers in a more efficient fashion. We think that had a really transformational effect on their ability to build these machines, and got them into a better position, profitability and capacity-wise. That is what we're doing in Fujitsu with AI.
I've got a quick question. Martin, thank you very much for that. That was really useful. I particularly thought the project and case study that you did on the turbine blade was of much interest to me. The question I've got is, when you were looking at the convolutional neural network and you were doing the analysis on that, compared to the technology that you were using at the time, what kind of performance benefit would you get from using DLUs on that?
Okay, so at the moment this platform is built on GPU, so using the current technology. When we move to the DLU, we expect to see in the order of 3 to 6 fold increase in performance, also with a significantly reduced power footprint, power demand as well. So it reduces power consumption and increases speed by in the order of 3 to 6 fold.
Okay, thank you very much for that. And if people want to see the DLU in operation, would it be a good idea for them to head down to your world tour, for example?
So the DLU will be talked about at the World Tour, but it's not actually in production yet. They're still going through the final processes of getting the. It's a physical chip which needs to be designed and go through a fabrication plant, etc. So the final steps in those processes are still taking place in Japan and the Far East, but it's something we'll be talking about extensively at World Tour. Yes.
Understood. And if anyone's really hot for a demo, we can come back to them and let them know once it's been tested, gone through the full quality process, and is available for usage.
Yes, and in the background, we're also in our labs, we'll be running comparative analysis between the DLU and other similar machines, so we can publish data on standard benchmarks of what the performance benefit might be in terms of speed up and in terms of power consumption.
Appreciated, Martin. Thank you very much for that.
Duncan, we have a question from Costas.
Nice. Fire away.
Hello.
Excellent. Well, I have two quick questions. One on the DLU. If you could comment on the solution, on the silicon maybe. Is this going to be an FPGA or another ASIC solution, or what the solution would be? And on the A64FX, is there a roadmap ahead for further upgrades to the nodes?
Okay, so taking the first one first, yeah, the DLU is it's not an FPGA. We do use FPGA during the design process, so there will have been at some stage an FPGA version of it built and assembled in the labs, but that will be used for design evaluation purposes and ensure that we've got the logic correct in there before we go to a fabricated build. But yes, when we go to the build, it is, you know, it's a silicon implementation, so it's proper die masking, dies which then get assembled into chips and put into packages. And the package for a DLU will be in the order of 1.5 inch square multi-pin grid array. So that's the process that's currently ongoing in Japan and the Far East at the moment. In terms of the 64FX, yes, that is that refers to one particular version of the platform, and there will be a roadmap which will be released. I think it will be released at the ISC conference, which is in Frankfurt in later this month, 2 weeks time, and that roadmap will then become public domain. But yes, there is a roadmap that follows it. Yeah.
Thank you so much.
Hi, Martin. Joseph here. My question really is on the application of AI to utilities. I know you mentioned fiber optics routing and some stuff like that. Could you expand more on that, on how you can apply this to typical utilities now and in future?
Sure. So what we're looking at is with some of the telcos in Europe and in the Far East, we're looking at optimizing the deployment of infrastructure, and that's what they're looking at. And part of this is led by the upcoming 5G. So there's quite a complex algorithm to work out where do you place your base stations and how do you most efficiently route data to and from the base stations, and some of those are attached to the core of the network via microwave link, which is quite straightforward. It's relatively low cost, but you need a license for it. And some of them are linked to the core of the network via fiber optics. And those fiber optic routes become a critical part of the network, both from a maintenance and support perspective, but also from a security and infrastructure safety perspective. So that we're working to try to work out, given what the telcos know about their existing subterranean infrastructure, where they've got ducts, etc., and given where they want to put the new 5G base stations, how do they most effectively use the existing infrastructure to get to the points that they now need to go to? That's quite a complex task over something the size of a country, and that's where we're working with them at the present.
Okay, thanks for that. But in terms of application in electricity supply industry, Is it something that you've considered or thought about?
Yeah, so we're in the electricity supply. We have been doing some work, not in the UK, but we have been doing some work in Europe with a utility company, but that is around using predictive analytics and AI techniques to evaluate what the future demand is going to be for that particular provider. And that again, a bit like the fiber optic cable, it sounds like an easy question, but actually it's quite a difficult scenario because the number of the number of sources of power are quite large, as you recall from that the black and white diagram I put up with the little dials on it. Each one of those is a potential source. Some of the sources are the obvious ones, like coal, gas, wind, solar, etc. But some of them are less obvious, and so the things like the interconnects from well, the way the power supply tends to work is it tends to go from east to west. So as it's a follow the sun type approach. But as demand is, as production is increased in a country in the east, its demand will then drop off before the production does, typically. And then there's a drawdown of power to the next country to the west. So we in the UK utilize power from France once they've gone off peak demand. We've recently installed an interconnect into the Low Countries as well, which has come online in the last few months. So again, as the Netherlands and France reduce their demand in the evening, we make use of the additional capacity because it's cheaper than spinning up the turbines spinning up the coal turbines and gas turbines in the UK, and then consequently it then flows again after our peak demand. We can sell the power energy quite cheaply into Ireland as well, and that's the kind of complex equation that we're trying to solve with some of those countries. And that changes. It's not straightforward because it changes every day. But, the wind pattern, the solar receipts are different hour by hour as well. It's quite a complex evaluation.
Thank you.
Hi, Joseph and Martin. Duncan here again. Joseph, with the specifics of the conversation we had the other day, there may be some sense in us having a catch up with Fujitsu just to talk about potentially what we could do with the data that you're collecting at the moment and are planning to collect in the future. So let's see if we can take that one offline, maybe do a little mini phone call workshop just to go through what we could potentially do to deliver some more value back to you.
That sounds great. Good, thank you.
So thank you for that, Martin. We're now going to go over to Tam. So Tam, you are in control.
Thanks, Duncan. So my name is Tam Dipper. I'm going to be giving you a quick brief about some of the issues, risks, and the opportunities any of you should be aware of if you're in a small, medium enterprise, SME. And that's from my very personal perspective. I've been doing a lot of work recently for the UK government, but in no way should you infer that anything I'm about to tell you is actually official government policy. A lot of it is based on that experience, but it's also been reinforced by some academic academic research that I've been doing for this talk. And just as a quick bit of background, jargon-wise, stakeholders are everyone that you need to complete your project. So these are the people who give you resources, give you permission, they're market influencers, and of course the end users. So when I'm talking about risks, what we often think about are enterprise risks. So our non-technical stakeholders, that is usually strategic planners, see the risks as the AI delivery gets delayed, the infrastructure costs rise, or they have insufficient developer skills in-house. What this often leads to is outsourcing. And I'm not adverse to outsourcing, but the problem as I've experienced it is outsourcing without understanding what risks you're actually outsourcing and how you intend to. And if you don't see that, you can't have any assurance that the person you're outsourcing to is actually going to deal with that. So the key point is that outsourcing risk is not the same as mitigating it. The kind of risks that we can mitigate are technical risks, and these are the ones because our technical leaders, probably most of the audience, can actually get a handle on, can do something about. My research indicates that the three key technical risks of AI development are, firstly, that the problem is not clearly mathematically defined. Secondly, that the solution algorithm is not clearly defined, or that it's not really understood, which is often a problem with self-taught AIs or even guided AIs. And finally, that the testing algorithm and data is much more difficult than is usually expected. Running a good test on an AI, once it's been trained, is not actually as simple as people often think. It's not as simple as running a demonstration. So how do these risks connect? Because it's important to connect the technical risks back to your stakeholders. If the task of the AI is not clearly defined, that causes delays, because as your understanding of the problem evolves, your goalposts move. If the solution algorithm is not clearly defined, then it will cause you resource issues, because as the algorithm and its data needs evolve, your infrastructure will expand. You can often end up needing a vastly more computing power and data storage space than you initially thought. And finally, if your testing algorithms and data are problematic, that causes the perception of weak developers, because your understanding of the AI outputs and your perception of control, that is the usually user's perception of control, evolves. And they have the feeling that the developers aren't in control of the whole, aren't managing the process properly. So to take an example that I can talk about, autonomous vehicles are something that's of interest to both private industry, private individuals, and also of interest to governments in various different ways. There is a huge impetus to get autonomous vehicles to the market. But despite all of that, we have had some very recent, very highly publicized incidents where confidence has been undermined, publicly that is, by some accidents and uncertainty, I think, on the part of the general public about what is actually involved with these. If they buy an autonomous vehicle or get into one, what are they actually getting into? They don't understand that. And that I suggest that these problems arise because the objective problem is messy. Civilian transit in particular, it occurs for a variety of different reasons, and therefore some of the solution, some of the problem is not clearly defined. I think the algorithms are opaque. There are very many variables in play, and understanding why a failure has occurred is certainly not being made publicly available. And finally, the lab testing and the real world testing mismatches. So we have systems which are, sailing through lab testing with flying colors. There's an awful lot of confidence in them, enough confidence to put them onto an actual road. And unfortunately, there have been fatal consequences of some of these, this mismatch. So the question then becomes, well, what do we do about it? And I would like to suggest an operating model, which is that you need to have, when you're setting out to expand your use of AI, what you need is a centralized technical leadership of AI within the enterprise. This leader or leader group has to have a clear plan, and they have to have clear stakeholder buy-in. They also need clear technical authority and commonality in terms of the architectures and commonality in terms of the standards that they're using. This is actually something that government's quite good at in its own way. It's not flawless, but yeah. But while you have that central authority, you also need to have a federated use and development of AI. And by that, I mean that you need to start with your specialist areas that are very well understood problems that can be clearly mathematically defined. These are often quite almost scientific because of their very nature. These tend to be quite low-level problems, as I'll show you in a minute. And you need to put your human experts at your leading edge. They need to be the people who deeply have that deep understanding, as well as can define it clearly. You need to be prepared to innovate. You have to be prepared to integrate your various different kinds of AI, but you need to grow those elements of AI together. Don't just glue them together, or don't expect them to just fit together like a jigsaw puzzle. That won't work. When I talk about different levels of AI, I've done a very crude view of this. A lot of the time what we're talking about is sense making. So the ability to fuse an optical camera with an infrared camera, the ability to analyze faces, to identify a face in a image. This is what I would refer to as a sense-making AI. Multiple sense-making AIs usually lead as inputs to an analytical AI that has some kind of business purpose. But each of those business functions then business analytical functions feeds into a business function. And I would suggest that at the moment, we're mostly using sense-making AI with a degree of analytical AI. A good example would be the Martin's of the ability to use an AI to identify problem areas within the blades that they're assessing. To tremendous benefit. In the future, in the next 10 years, I think we're going to see that being taken even higher, and there will be business function AIs that effectively are unspoken members of the board in most SMEs. I mentioned earlier that you need a clear technical authority. That the roles of that technical authority are cross-cutting. So although you have multiple different AIs being developed, your technical authority will define and maintain the problem. They will verify and validate solution algorithms, and they will verify and validate testing. Now, how do you do that? Well, a lot of us, especially if you're working for an SME, won't have the ability or won't feel you have enough confidence in your ability to do all of that. A really good way, which actually the government is increasingly using, is to form an alliance, to form a partnership across academia, industry, and service providers. What I would suggest the best roles are academia are really good at designing mathematical definitions, both of the problem and the solution algorithm. And they are very, very good at designing a test for your AI because they're independent. So they're not, especially if you keep them separate from your development process, they are a good referee to come back and throw spanners in the works so that you can have more confidence. Infrastructure providers like Primenet can be flexible and responsive because, as I said, your goalposts are going to be constantly moving as your AIs develop, as your integration of AI into your business develops. You need flexibility, and I think I've seen that it's excellent to have that opportunity to spin things up and extend things. And finally, I mentioned this idea that we outsource things without really thinking about them. As I said earlier, outsourcing is not the problem as such. There are some really good ways that you can use AI producers. If you're using AI as a service, you can get some specialist applications which are already excellent and are enterprise agnostic. So if you were a hospital, not suggesting anyone is in the audience, but then there are some really good tools out there already for cancer identification. You don't need a bespoke cancer identification tool necessarily. You can integrate that as it is, as a service. But you can also take AI as a platform. So if you have common development tools and standards, these are actually very, very helpful to your technical leadership to help, because your aspiration should be that when you're developing AIs, you are building towards a future where your multiple different AIs talk to each other and you're getting the full benefit of them. And having a common development suite is one way to foster that. Okay, that's the end of my talk. If anyone has any interest in some further reading, which I doubt because everyone's very busy, but if they are interested, feel free to contact me through through Duncan, and I will forward you a reading list.
Thank you very much for that, Tam. That was really useful.
Thank you.
Just before we end, next steps, everyone. I'm very keen that if you do have an idea or you want to have a conversation with anyone who was on the webinar today, that we make that available. One thing that has proved really useful in the past, if you do have a good idea, is to get involved with Fujitsu. They've got a digital transformation centre down on Baker Street in London. And whilst you're down there, they'll help you understand, look at, and develop your AI from an idea into something which can actually be tested. So Fujitsu have worked with quite a few different partners in the past. They're happy to commit time and resources to help you develop your idea if it's got some legs. And we're very happy to facilitate a conversation if you do have a good idea around that. Here are my contact details. Do feel free to call through to myself or to Ron.
So I think we got one question from Stefan. Hello.
Hello, can you hear me?
Yes.
Yep.
Perfect.
Hi.
I was just curious if the slides are available after the presentation.
Of course
I have no
they are.
objection.
Yes. My ones, definitely. What about you, Martin? Are you happy to share yours?
Yes, no problem.
Fantastic.
Sam,
Thank you
are
very
you
much,
happy
guys.
with yours?
Yeah,
I'll take
absolutely.
care of it.
Perfect. We will make them available via Ron.
All right, we appreciate it. Thank you.
Great. Thank you, Stefan.
Right, I think
Okay.
that's about it. Thank you very much.